So definitely a lot of the progress will be done with non-invasive technology, but the real next big leap will be coming out from invasive technology. So what I mean by non-invasive versus invasive is the non-invasive one is from outside your head. So we put a cap with electronics, with electrodes and things like that. Outside, there is no surgery, and it's not invasive for your body. In the other end, the invasive one is that will put something in your body. So most of the time with brain tech, we'll open your skull and then we'll put chip, electrodes, things like that, some technology on or in your brain to try to get a better signal. Because one of the main challenge with reading the brain activity is really the signal to noise ratio. So it's really like tiny activity. Your brain is super complex, and we're trying for really far from the brain when we look at it. When we're recording from your head, in your hair, for example, when we think about it, it's really far from the signal, given the ratio, like strength of the signal, distance. I don't want to be too go into the details into engineering about it, but trying to read the brain from outside your head is really challenging. It's really hard to be able to have a good signal. So we're trying to go right at the source and be in the brain or on the brain to try to record right from it what's happening. So the big dream would obviously, if we try to think about nanobots, for example, like nanotechnology, really small, tiny technology that we could have all over your brain to read everything in your brain, that would be like the holy grail. So that's where some research is trying to go. Recently, we've seen a lot of Elon Musk talking about things like neural lace. So Elon Musk recently, not only is he taking a stand on AI, but also now instead of AI, humans to stay relevant in an AI and robotic world, we need to merge with machines. So basically brain-computer interfaces. So we need to be able to communicate with our brain directly to the machine.
So given all this dependence on brain and basically interfacing with the brain, how closely does your field partner with actual brain scientists, scientists who are, actively trying to understand how the brain functions and topic of that nature?
Yeah, so more and more, obviously, because brain-computer interfaces is a multidisciplinary field. So you need engineering, you need electrical engineering, you need computer scientists, you need machine learning experts, you need neuroscientists, you need people that are more in the psychology, cognitive aspect things. So now it's really multidisciplinary, and now we're seeing new kind of labs and research being done with all these areas being merged and combined together, because you cannot be a BCI expert and control kind of like the full pipeline from the electrical engineering to the really neuroscience. Normally, it's a team of multiple experts together that will work on a common goal. So that's really one of the challenges, that there are so many challenges in the pipeline that you need a full team now to work on it. But definitely, it's not I would say, a technology field as it is a neuroscience field. It's the combination of all of them together. So everybody is working hand in hand. More now, I would say, like 10 years before, it was still very siloed, and this is why the progress wasn't really fast. Now we have a lot of new multidisciplinary team in the field.
So once neuroscience does mature, basically, what are the breakthroughs that will enable that? Is it just the ability to read any brain perfectly? Is it the ability to read thoughts in real time? What are the specific abilities that scientists or technologists need to achieve in order to make the sci-fi representations of BCI a reality?
That's actually a very good question, because there is multiple scenario that can unfold that will lead to very good results, depending on what is the goal, what are we trying to achieve. So let me give you some example. If we're trying to control a wheelchair for locked in and paralyzed people, that's one thing. If we're trying to go very far and talk about mind uploading, trying to really like put your brain and back up your brain on a computer. Brain emulation, exactly. So all that space where the idea is really that the brain can be there is nothing more than the different. It's an engineering system that we can model with, for example, electronics and technology, and that we can reproduce and copy your brain, for example, on the cloud with technology. So we can talk a bit more about that because that's really exciting. That's really obviously a lot of controversy around that. And the other one is trying to understand the brain, for example, diseases, to cure diseases, understand consciousness, free will, things like that. So it really depends what the goal is. And different scenario will apply for different things. For example, if we're trying to understand free will and consciousness, then we really need to understand the brain at a like very small and very detailed level. If we're trying, on the other hand, to control a machine with our brain, maybe that can be a black box, and maybe AI can just learn. For example, if we take deep learning right now in the field, it's getting better and better at image recognition. And neural nets and deep neural nets are basically kind of a sort of a black box to some point where the machine itself just learns. You don't really know what it learns, but at the end of the day, you have an input and you have an output, and it works, or it makes sense at least. So that could be a very, and I think that there will be a lot of the breakthrough that will come from kind of black box machine learning, where we train someone, we say, do this, do that, and you learn. So it's kind of a relationship with you and the machine, where the machine is learning your brain and you're learning the machine to get the right output, but nobody really knows what's happening. So the machine doesn't really understand your brain, and you don't really understand what the machine is understanding from your brain, but it just works. At the end of the day, you're moving your wheelchair when you think about this or that. So that's kind of a black box approach. And I think that big data, as we get more and more people using this kind of device, I think that we'll be able to have some models that can differentiate some mental states and things like that with a black box kind of approach.